Hey, welcome back to the channel. Got a little something on the bench for you here. So we're going to be looking at the TuneRC. This is the EZ3 HD all-in-one flight controller. This is a 1S, 2S flight controller. I was looking at some 18650, 21700 builds, just kind of going through some different flight controllers, and I seen this one and I thought, you know, there's something interesting about this flight controller, something a little unusual. I reached out to TuneRC and I started asking questions. They went ahead and sent it to me, so I appreciate them for that. I get to put it into a build, I get to test it, I get to mess around with this, so pretty cool. I want to share some information with you. I want to do an unboxing, see what's in the box. We're going to get on the microscope. We're going to look at solder structure, some components. We're going to go through the specifications as fast as I can. And so that's what this episode's about, so stay tuned. All right, so over here at the bench, we'll go ahead and unbox this, see what comes in the box, and we'll go through a couple other little things. So the first thing we have is the flight controller. So we have some protective foam, some thick dents, and then some squishy. We have our flight controller, and there's both sides. I'll get into more of this, of course, as this video plays on. So we have an XT30, little pigtail, little XT30 pigtail. We have a cable going to a USB connector. So this is a adapter that plugs into the USB port, and the Type-C connector on the other side, so you can plug into your computer and do whatever changes. Also, what's kind of nice is you can plug this in, and if you were going to bury this flight controller into a build, you can plug this in and then have this kind of double-sided adhesive somewhere. You can access it a lot easier. So it's kind of nice in case you're going to do something like that. Receiver antenna. So this has an interesting ELRS receiver built into it. We'll get into more detail about that, but they do give quite a robust receiver antenna. I'll tell you why here in a minute. Some gummies. Looks like there's 6 of them. These are M2 gummies. They feel like they're all the same. So there's 6 of them in case you lose 2 of them maybe. So that's what's in the box. So we have our gummies, our XT30, USB adapter so we can plug into the computer, and flight controller, and our antenna. So let's go ahead and get some weights for you real quick. All right, make sure we can see our screen here. So we're in grams. I did penny weight my scale, so it's calibrated. So our flight controller weight is 6.4, looks like 6.48. With the antenna, it's 7.23. The antenna by itself is 0.7, looks like 0.75. Let's go ahead and get some measurements for you. All right, the flight controller in millimeters. Let's see here, we're going to have 33.85 by 30, you can see the screen maybe, by 33.32. And the thickness, so if I measure the thickness of the board, just the PDB here, 1.24. So kind of thicker than like a standard Whoop flight controller that you'd have for, you know, like a little 1S race Whoop or something like that. So a little bit thicker PDB, definitely going to be a little more robust in a crash and not flex and pop components. The overall thickness of the board, I'm going to measure from the USB. So the USB port to the largest thing on the other side, which is a ceramic capacitor. So we're looking at 7.34 millimeters thick. Okay. So let's go ahead and jump back over here. So this flight controller is quite unique in some of the features. We'll get into that when we get online here. Some of the things that I was looking at, so like a build like a toothpick or, you know, a little pick build. As you know, I've been a fan for many years of pick builds. Being able to do a DJI 04 pick build is kind of what I've been after. I just haven't seen anything that really caught my attention until now. So I'm not sure if I'm going to build something like this or if I'm going to go with, you know, dual 18650 or 21700. I think that build would be a little better, you know, on a different type of frame. I'm not real sure what I'm going to do as far as that. But if you're running a dual 18650 or a 21700 build now, in comments, I'd appreciate it if you let me know what your thoughts are about that. That'd be awesome. The other thing I want to show here, so we have, go back to the bench. I have like this is like a basic standard Pro frame and a regular Whoop frame. I just want to show you with the Pro frame, it's going to be kind of floating on top. It won't fit down inside there, of course, and it actually won't on a regular or a standard 75mm Whoop frame. It won't set down in there as well. It's a little bit too big to fit in there. Okay, I just wanted to let you know that, so it kind of will float. I'm sure you could make it work, but I just wanted to show that it does float on top. All right, before we jump over to the microscope, we're going to jump online here and we're going to look at some specifications, and I want to go through some of these unique properties on the flight controller. So let me go ahead and set this dude aside here. We'll go ahead and jump online. All right, so here on their website, TuneRC did a good job on their website. They got all the information on here. There's all these different tabs here, so you can see all the specifications, wiring diagram, what's in the package, all the type of stuff. Okay, they also give some of the other information. This is one of the things that I wanted to show you, the test points and then the power flow chart. So like I said, they separate in the circuit, they separate it. I'm going to show you here in a second on that. But real quick, it's nice that they put a breakout. So of course they have like the standard, you know, advertisement marketing pictures, and weight and measurement. They also do the breakout, and I like that for a manufacturer to put that on there because it's quick and easy access from my cell phone. If I grab my phone, I can, you know, quickly look at these breakouts in case I forget what's going on. I want to talk about this receiver a little bit. So this is a PA LNA receiver, okay, Express LRS PA, which is your power amp. So it's going to boost, it's going to amplify the power out. Okay, so your telemetry data that's in your screen. So if you're doing long range, like I'm wanting to do like something that flies around, kind of scouts out an area. So I'm going to do a little bit longer range, right? It has a power amplifier for telemetry. So all that data in my OSD, I can see, you know, what's going on inside the quadcopter. That telemetry data for most 1S flight controllers that I look at is 10 milliwatt transmission. Okay. So I'm having like, you know, if you're a fan of my channel for a while, you know, my Moby pick, I've been kind of playing with that. And then, I have another quad that I've done the antenna mod. So I have a video on antenna mods, to get that little bit longer range. So you don't have that telemetry loss, telemetry recover kind of stuff happening. With this, I just don't think you're going to have any issue because this is going to go from 10 milliwatts to 100 milliwatts. Most PA receivers are 100 milliwatt, transmitting back to your radio so that you can get that telemetry data. So the LNA, which is a low noise amplifier, that's what's going to give you a little bit more of an amplified, the signal coming in. So all of the movements on your radio, stick commands, switches, all of those commands that you're sending, transmitting from your transmitter or radio, they're going to amplify a little bit coming into the flight controller. So you're going to have less packet loss. If you're not really familiar with what exactly I'm talking about as far as packets, I made a really cool video a while ago about link quality and RSSI DBM. What's the relationship and why it's important to have both of them in your OSD. I would suggest go look at that because I kind of break it down as best as I could so that you could understand what exactly packet loss and all that kind of thing means. But with this receiver, I don't think you're going to have an issue with that because of the amplification that they're working with here. So I thought that was a pretty unique thing, and that's why I wanted this flight controller. Also on the flight controller, of course, we're getting into the microscope. We'll look at these things a little closer. I just wanted to show you this. LEDs, so you can do the troubleshooting. You can see the power LED and other diagnostic LED. course, your motor pads, and then you have your compass and your GPS, UART, you have your voltage for that, and then your battery positive and negative, other motor pads, and then the 9-volt and ground. So here's kind of the other thing that I thought was neat about the flight controller is they separate it in the circuitry. They separate the power, so they have the 9-volt separated from the 5-volt. So all the things, the components on the flight controller themselves are being ran on a separate circuit. So they've actually broken it out. I thought that was unique. Of course, I haven't flown it or tested it or anything, so I'm not sure what the outcome of that's going to be, other than I feel like it's going to allow us to not brown out our video as bad or at all. I believe that we're not going to have an issue with brownouts in our video. Currently, I've had experienced other flight controllers that I've hooked the DJI-AIO for, also the HD0 and things too, that just had issues. Once you get down to low voltage and you punch out, or you're sending it against the wind to come back, and you just get that voltage too low, and it just browns out and you lose your video. That's kind of a bad thing when you're flying FPV, right? So I think that this is unique because it's going to eliminate some of that from happening. Of course, if you run your LiPo or your battery down too far, it's inevitable. It's going to happen, and shame on you. So, but anyway, buzzer and 5-volt. So again, a small little build that's going to be flying who knows how far or whatever the case may be. I definitely want to have a buzzer on it. It's nice that it's on here. LED ground and 5-volt. So we have our Betaflight addressable LED capability. So that's kind of nice. You can light your quad up. Of course, if you're just using a cob light, you can use the ground and 5-volt. On the other side here, we have so what I just showed you was the breakouts. They actually have breakout pads so you can solder. You know, I like to solder everything. I feel like the connection just lasts longer, less hassle is a connector. So that's this side. So of course we have our video, 9-volt and ground, and then we have our UARTs. It does look to me that you can swap and like you can disable the ELRS receiver built in and go with the S-bus on the DJI. That's what I'm assuming by looking at this. If you have this flight controller already, I'd like to know if you're running the DJI-AIO 4 Lite or Pro on that. I didn't see any component in here that allows you to remove that. And then of course over here we have our compass and our GPS. So you might think like, oh, can you do position hold with this? Well, of course, because this actually has a built-in barometer as well. So we have a barometer, we have our UARTs for compass and our GPS, and 5-volt and ground. So you could plug that right in, run your connector right to your peripheral. So pretty cool. Like I said, there's a lot going on in this little compact flight controller, and it's either 1S or 2S. So let me, I just want to let you know that TuneRC, I don't have any affiliation with them. I just seen this flight controller and thought it was really neat, and it had some features that I liked, and they sent it to me. So that's the only relationship that we have. Born for 1S and 2S builds, so they go through all this information. 12 amp MOSFETs. We'll look at the MOSFETs and the micro camera a little bit closer. There's the built-in ELRS I was talking about, and the 4 UARTs built-in barometer. 8 megs of black box capability built in. 8 megs will get you done for tuning reasons. Probably not going to be able to do like stick overlays and stuff for very long. A lot of flight controllers are like 16M, but this, like I said, this dude's pretty compact. Take a look at this real quick. So in here we have some documentation, but I thought it was kind of cool that the test pads are broken out. So if you're wanting to do some future diagnostics or stuff like that, they actually broke out the test pads here. So that's kind of neat. If you're not familiar with test pads, I have a video. I believe it's a short, so you could see what a test pad is and what it means. So here's what I wanted to show you. Okay, sorry about that. Knock my microphone over. Here's what I wanted to show you. That this is where they're showing here in this diagram that they've separated the video power supply, the 9 volt, and then the 5 volt and others, so the 3.3 for your components on the board. That's actually separated. So that's kind of nice that these components shouldn't be conflicting with these components when it comes to power. And then also, it should help with brownout. So when you're doing a lot of maneuvers or you're doing a lot of processing, your accelerometer and all that stuff, it's not interfering with your video. So I would assume that this would have a pretty good video system, no browning out. I haven't tested the capacitance of the board itself yet. It doesn't appear that there's a whole bunch on there. You could add like a 220 microfarad capacitor to your pigtail just to kind of help with that. It kind of gives you that little bit of reserve for a spike. But honestly, I don't think you'll need it if they truly separate it circuitly. So there's the diagram. You can look at that on here. You just go click on that. So there's a decent amount of information on here. Of course, you have the specifications of all the things I just talked about. So lots of things to look at there. So let's jump on the microscope and let's look at the solder structure and then some of the components they might use. And I want to show you the barometer up close. So let's go ahead and take a look at that real quick. All right, so the first thing on the microscope I want to show you is the silkscreen arrow here. So this would be the front of your quad, and this would be the back of your quad. So the silkscreen arrow is pointing towards this mounting point. This is a diagonal mounting point, like a 25 by 25 loop style mounting point. So there's your silkscreen arrow to let you know orientation. Here's all the receiver components. So this is your ELRS receiver component. And here's the LED that's going to indicate whether it's in bind mode or if it's having some issues, or also it'll show you if you're in Wi-Fi mode. Your bind button, your antenna, all of these components here. It looks like the flight controller itself has some pretty good filtration on it. I'll just kind of rotate it around so you can kind of see all the different components here. As you can see, this is the flush side of the board. So we have a BB51. I'm a big fan of the BB21, but it seems like a lot of people are using the microcontroller. BB51 has kind of been a more popular controller. And then you have 2 MOSFETs on this side and 2 MOSFETs on this side for the motors. And then there's another MOSFET on the other side. See if I can get the silk screen for you on the MOSFET. So they're boasting 12 amp. So you have 12 amp per corner. So that should be able to sling quite a bit of motor, really. Then you have your physical boot button is right there. And then your solder pads. So your power in. Here's your shunt resistor. This will give you your voltage in your OSD. So this is what Betaflight is looking for. Voltage controller. Voltage processor. The voltage regulator, I do like that one quite well. It's a much nicer one than some of the other ones that have been used. So decent amount of filtration, but like I said, I'm not really seeing a ton of capacitance. Whether they need it or not. What's going on here? Take a look at this little dude here. All right. Quite a bit of solder on this. So what I like to see, let me go ahead and refocus this for you. I like to see the solder ramp up. If the solder is barely any there, or it has like a sharp 90 degree, meaning there's not as much solder, I kind of worry about components. We like to use double-sided adhesive. Tear them off of there if they didn't get enough solder on it. But this looks like it's got quite a bit of solder. Let's go ahead and flip it over and look at the other side. TuneRC silk screening. So we have our connector here. We have our processor. Let's see if I can get this in focus for you here. All right, so we have our processor, and you can see the amount of solder. Let me see if I could tilt this up for you here. Focus it. Yeah, it's pretty decent solder work on it. I don't really see any like components that are kind of whopper jawed on there, so that's good. Here's that barometer. Now I like to put a little piece of foam over this, like a fine open cell foam. So because this side of the board would be up in my build, it's kind of nice. I could squish a little piece of foam in there. So, you know, like your microphone you put on your lapel and it has a little fuzzy thing on it to keep the wind from interfering with it. It's kind of the same scenario. All of my quads that have a barometer, I like to put a open cell, fine open cell foam on it. If you don't have any fine open cell foam, go to your wife's makeup cabinets and take the little sponge off the makeup brush. Don't tell my wife that's where all hers has been going, but that does pretty good too, because the barometer, that hole right there, is where the barometer gets its information. So if the wind is constantly pounding on that barometer, it doesn't give you a real accurate reading. All right, so you can put motor plugs if you're running like a 1S motor and you have motor plugs, but there are none in the box that I've seen. So you'll have to supply your own motor plugs. So this would be the other side. On this side of the flight controller, you can see the motor pads are decent size. I would definitely use some flux or rosin paste before I solder my motors on, just to keep bridging from happening here. It is pretty tight, but the pads themselves are quite large. Yeah, I'm not really seeing anything on here that like sticks out like a sore thumb. Let me get the silk screening here so you can see what that dude is. And then we have quite a sizable coil in here. You can see all the filtration and everything for the voltage regulators, and then the separation of power. So we have our 5 volt and we have our 9 volt. So everything looks pretty tidy on here. Trying to film and talk and also think at the same time. Let's go ahead and jump back over to the bench. All right, so I feel like we went through quite a bit of information on this flight controller. Just kind of wanted to go through everything with you as far as like specs and some of the things that I thought were interesting about it. Let me jump back over here. So, like I said, if you have any questions, let me know in comments about any of the information I've covered in this. Once the hobby dollars come in, you know, hopefully, you know, we get some hobby dollars sometime to make this build a reality. I'll have more information on the channel. But for now, if you have any questions about what I've covered here, let me know in comments. And always try to catch a live stream, Propsoff, hang out with Propsoff, Q&A, or basically any live stream. I'm not real particular as far as I can answer some questions. Hang out, just hit that notification bell. Hopefully this helped you out, and if it did, you know, give me a thumbs up, subscribe to my channel. If you hate it, you give it a thumbs down. It all works. Enjoy the breeze.